Hello everybody, welcome into another lesson. So today we are starting the unit on the factorials, permutations, combinations, and the binomial theorem. Today we'll talk about those first three items. We're going to talk first about factorials. So a lot of you may have seen any number, arbitrary number n, with an exclamation mark. That exclamation mark is a factorial. It doesn't mean that you're yelling like 2 or 3. It means 2 factorial or 3 factorial. So what is a factorial? You take the number itself, you start with the number to the left of the factorial sign, then you multiply it by one number less than that, then another less than that, and it keeps on going and going until you reach 1. So let's do some examples here. Let's say I have 2 factorial. So 2 factorial, well, that's just going to be 2 times 1, which in this case is 2, right? Now, what if I had 3 factorial? So I have 3 factorial. Well, that's going to be 3 times 2 times 1, which would be equal to 6. So 3 factorial would equal 6. You start with the original number to the left of the factorial, then multiply it by one less number than that, then the number one less than that, until you reach 1 for your last multiple. Let's do a couple more of these. So let's say I had 4 factorial. So 4 factorial, that's going to be the same as 4 times 3 times 2 times 1. So that would be 24. So 4 factorial actually equals 24. Alright, now, last one of these, let's say I have 5 factorial. So if I do 5 factorial, that's the same as 5 times 4 times 3 times 2 times 1. So that's 20 times 3 is 60 times 2 is 120 times 1, that's 120. So 5 factorial would actually equal 120. So that's what the exclamation mark means after a number. So you get the picture. We could go to 6 factorial, 10 factorial, or it'd be god-awful to try to do 100 factorial. Now, most calculators thankfully have that function, so you don't have to sit there and write out each number less. If you just put the number into the calculator and the exclamation mark next to it, it'll do the factorial for you. In fact, I have yet to see a calculator that doesn't, so pretty much all of them have it, which is good news. Now, a couple special factorials. Let's say we have 1 factorial. That just equals 1. You will sometimes see that. And then 0 factorial. 0 factorial equals 1. There are proofs of that in later courses, but for now it's just easy to accept that 0 factorial equals 1. Now, if I attach a negative sign in front of 3 factorial, so I take negative 3 factorial, that is the same thing as taking negative 1 times 3 factorial, which would just give you negative 6. So if you have a negative sign on the factorial, it's just the same as taking a negative 1 times the factorial. Now, on the other hand, let's say I have in parentheses negative 3 quantity factorial. What happens there? Well, a factorial is not defined. It is not defined for negative numbers. A factorial will not be defined for negative numbers. Also, what if I did 1/2 factorial? Also not defined. Now, when you get into later courses like advanced calc and more abstract courses, there are pseudo ways of doing fractions that are factorial or decimals that are fractorial, and there's even ways of dealing with negative factorials, but really in the set of real numbers, these don't exist. Factorials only work for the set of whole numbers, which are every number 0 and greater that are integers. 0 and all the positive integers. Alright, now we have a couple applications of factorials. We have what's called a permutation. We are going to talk about first a permutation. That's when you have a set of items. So a permutation is a set of items taken so many at a time where order matters. So a permutation is a set of items taken so many at a time where order matters. So here's how the general formula is written. You'll see a big capital P. To the left of it, you'll see a lowercase n. To the right of it, you'll see a lowercase r. This means the permutation of n things taken r at a time. This is where order matters. Like, you know, it's funny because the next topic's called combinations, where it's a set of items taken so many at a time where order does not matter. And you would think with a combination lock, really they would want to call it a permutation lock because the order does matter for combinations. So that's kind of ironic if you ask me, but a permutation is so many things to the left taken so many things at a time. N things are at a time. So the formula for that is going to be n factorial all over the quantity of n minus r factorial. So that is the formula for permutations, n factorial over n minus r factorial. So we'll do some examples of permutations. So let's say here, let's see. I'm going to do the permutation of 3 things 3 at a time. So I'm doing 3 things 3 at a time. So to the left is my n, that's 3 factorial. And then to the right's my r, so this would be 3 factorial all over the quantity of 3 minus 3 factorial. Which in this case is still 3 factorial, but this would be over 0 factorial. So this is going to simplify into 3 times 2 times 1 all over 1, which would give you 6. So there are 6 possibilities for 3 things taken 3 at a time where the order does matter. That's how many possibilities you have to arrange a set of items or a set of numbers or something like that. Alright. Now, let's keep this up here. Let's say I have a set of 5 items that I'm going to take 2 at a time. So I'm doing the permutation of 5 items taken 2 at a time. So this, of course, my n is 5, so this would be 5 factorial all over the quantity of 5 minus 2 factorial. Well, this would simplify into 5 factorial all over 3 factorial. Now here's some good news with factorials. you can break down factorials like that 5 factorial. You can break this down into 5 times 4 times 3 factorial, because after all, your 5 factorial is really 5 times 4 times 3 times 2 times 1. Well, that 3 factorial is the 3 times 2 times 1. So that's how you can break this down. This would all be divided by 3 factorial. And what do you know? Your 3 factorials cancel out. You just get 20. So the number of permutations for 5 things taken 2 at a time, since the order does matter, gives you 20 possibilities. Alright, let's see. I'm taking the permutation 12 things 3 at a time. So I'm doing the permutation of 12 items 3 at a time. So my n is 12, so this will be 12 factorial all over the quantity of 12 minus 3 factorial. So this would become 12 factorial all over 9 factorial. Alright, well, this will turn into 12 times 10. Wait, why am I skipping 11? I have a tendency to do that sometimes. 12 times 11 times 10 times 9 factorial all over 9 factorial. Well, your 9 factorials are going to cancel out. That just becomes 12 times 11 times 10. So you have 121 times 10. That would be 1,210. So the number of permutations for 12 things taken 3 at a time is 1,210. I got one more permutation, then we'll move on to combinations. Alright. I have the permutation of 16 items taken 0 at a time. So I got 16 items taken 0 at a time. So that's going to equal, of course, my 16 factorial all over the quantity of 16 minus 0 factorial. Well, that would equal 16 factorial all over 16 factorial. These cancel out. You only have one possibility. If you take 16 items 0 at a time where the order matters, you have only one possibility of a permutation. There's only one permutation for that. So that's permutations. Now let's talk about combinations. So combinations. A set of items taken so many at a time where order does not matter. So a combination, you have a set of items taken so many at a time where order does not matter. You can arrange it in any order. The notation for a combination is a capital C, but to the left of that capital C is the N, to the right of it is the R. So this is the combination of n things taken r at a time. It looks similar to permutation, only it's got a capital C, but the formula is slightly different. The formula for a combination is going to be n factorial all over the quantity of n minus r factorial times r factorial. So you have that extra r factorial in the denominator for a combination that you have to figure out. So let's do some examples of that here. Gotta flip the page here. All right. So let's say we have the combination of 10 items taken 2 at a time. So we're going to do the combination of 10 items taken 2 at a time. So that, of course, is going to equal 10 factorial divided by the quantity of 10 minus 2 factorial times the 2 factorial. That's what the combination would look like. Okay, so let's see, this would turn into 10 factorial all over 8 factorial times 2 factorial. Well, here in the numerator, you can break that 10 factorial down into 10 times 9 times 8 factorial divided by 8 factorial times the 2 times 1. Well, your 8 factorials are gone, so this makes it a little more bearable. And then 2 goes into 10 5 times. So this will literally become a simple 5 times 9, which we know 5 times 9 is 45. So there are 45 possible combinations for 10 items taken 2 at a time. All right. Now, the combination of 8 items taken 5 at a time. So we're going to take 8 items 5 at a time. So my 8 is my n, so this is going to be 8 factorial all over the quantity of n minus r factorial. So that'd be 8 minus 5 factorial times my r factorial, which is 5 factorial. So this would simplify down into 8 factorial all over 3 factorial times 5 factorial. Well, now in the numerator, that 8 factorial can break down into 8 times 7 times 6 times 5 factorial. All that divided by, I still have my 5 factorial here, but my 3 factorial, that'll break down into 3 times 2 times 1. Well, my 5 factorials cancel out. 3 times 2 is 6, so those and the 6 will cancel out. I'll literally just have 8 times 7, which means there are 56 different combinations at this point. So for 8 items taken 5 at a time, there are 56 possible combinations. Two more. So I'm going to take 14 items 6 at a time. So the combination of 14 items taken 6 at a time. So that equals my n factorial in the numerator, which would be 14 factorial all over my n minus r factorial. So that'd be 14 minus 6 quantity factorial times my r factorial, which is 6 factorial. All right, so this will turn into 14 factorial all over 8 factorial times 6 factorial. All right, well, good news is 14 will break down, so this will be 14 times 13 times 12 times 11 times 10 times 9 times 8 factorial divided by my 8 factorial times 6 times 5 times 4 times 3 times 2 times 1. Well, my 8 factorials will for sure cancel out. My 4 times 3 will cancel out with 12. What else? My 5 and 2 will cancel out with 10. So what's really going to be left here, you're going to have 14 times 13 times 11 times 9 divided by 6. So it's a little bit better, but let's figure out what the heck that is. So you get 3,003 possible combinations. So if you have the combination of 14 items taken 6 at a time, you get 3,003 possible combinations. All right. One more. I'm going to take the combination of 11 items taken 3 at a time. So I'm going to take 11 items 3 at a time. So this will equal in the numerator my 11 factorial divided by the quantity of 11 minus 3 factorial times the quantity of my 3 times 3 factorial. Okay, so this will simplify into 11 factorial over 8 factorial times 3 factorial. So the 11 factorial will break down into 11 times 10 times 9 times 8 factorial all over 8 factorial times 3 times 2 times 1. Well, my 8 factorials will cancel out. Let's see, 3 goes into 9 3 times, 2 goes into 10 5 times, so this will literally turn into 11 times 5 times 3, which should equal 165. So the possible combinations for 11 items taken 3 at a time are 165 possible combinations. So that's it for this lesson. Next lesson we'll start a 2-lesson series on the binomial theorem. So the next lesson will introduce the binomial theorem, and this has a lot to do with combinations like we talked about today, but it's going to be if you have a binomial to a power and how to expand it. The next particular lesson will simply just find the coefficient of a particular term, or even find a particular term without having to expand the whole thing. The lesson after that will expand the whole thing. So I hope everyone has a great night. Take care.